Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, we think we've got an informative topic for you today. Here it is. How to test BACnet IP and BACnet MSTP prior to on-site installation. Now, as application engineers and automation engineers, we know that testing in our own facility of the equipment we're going to supply to our customers is critical as a first step to making sure everything goes well on installation and startup. So, when we're talking about BACnet, how are we going to test our machines that are going to be installed in that BACnet building automation environment? What kind of tools do we need to make that happen? Well, that's the topic we're going to cover today. And today's mostly going to be about the demonstrations using some test software. We've got a few slides for you, but we'll keep those to a minimum. All right, let's dive right in. We'll break down the topic as follows today. Now, we've only got a short review of BACnet because we just covered it last week, and we have several detailed videos available on our website and on our YouTube channel that talk about BACnet in detail. So just a really quick review today. And we're really then going to dive into what you need for testing, and then demonstrations on testing BACnet IP and BACnet MSTP. All right, let's get going. Okay, so here's our quick review of BACnet. BACnet stands for Building Automation and Control Network, and it effectively allows building management systems to interface with a wide variety of equipment from multiple manufacturers. It's really become kind of the de facto standard for building automation networks, certainly in North America, and it's got worldwide appeal as well. Now, there are two primary BACnet network types. We have BACnet IP, which is Ethernet-based, and we have BACnet MSTP, which is RS-45-based. And they both can coexist in the same facility, the same campus, with things like BACnet routers, which will take a BACnet MSTP network and make its devices available over the BACnet IP portion of the Ethernet network. And then, of course, you have devices that just sit right on BACnet IP directly. Okay, now there's a couple key terms. We covered a bunch of them last week, but here's just a couple to remind you. First of all, in BACnet, there's something called a device ID. Now, this is a 22-bit identifier. It can be up to about 4 million in value. But the idea behind that is that a device ID has to be unique across an entire facility or an entire campus, okay? Whereas an MSTP MAC ID only has to be unique across a local MSTP network. And on a typical facility or a typical campus, you might have, several or dozens MSTP networks, and a MSTP MAC ID just has to be unique for that local network. And typically, if you've got devices that can handle the token, and MSTP stands for token passing, at least the last two digits do, then any device that handles the token, which are effectively called masters, need to be addressed between 0 and 127. So a MAC ID is a byte value maximum with masters using the first 7 bits or 0 to 127. Now, what are you going to need at your facility to test your machine over BACnet so that when you install it at the customer site, you've got a pretty good assurance that things are going to work the way you want? Well, BACnet is a client-server network. That's the model it uses. And effectively, or typically at least, OEMs and system integrators are providing equipment that is going to act as a BACnet server, okay? Which means if you're going to test that, you need BACnet client software to do the testing. Now, if you want to provide both BACnet IP capability as well as BACnet MSTP capability, then you're going to have a physical connection to your controller as well. If it's BACnet IP you want to test, you're going to need to connect over Ethernet, which is a lot simpler, obviously. And if you're going to connect over, or if you're going to utilize BACnet MSTP or allow your customer to utilize BACnet MSTP, then you need to connect your BACnet client software to your equipment over RS-45, which probably means a USB to RS-45 adapter on the same computer that's running the BACnet client software. That's certainly what I'm doing for my testing here on the bench here at my lab. Okay, now you can go to the BACnet.org website and you will find all kinds of commercial software and test equipment for BACnet. There's just a bunch of it, and I'm sure a lot of it is really good stuff. But if you're just looking for a down and dirty utility that is effectively open source and freely downloadable, then a good place to start is something called YABE, which stands for Yet Another BACnet Explorer. And you can download that, again, freely from the web. And there are better tools, I'm sure, and there are commercial tools that come with support. So I'm not saying don't use those, but a good place to start is with YABE. And in the case of YABE, it supports both BACnet IP and BACnet MSTP. So if those are the networks you want to support, then it's a tool that you can use for some basic testing. Okay, so what are you actually looking for while you're performing the testing in your facility before you go to the customer site? Well, the basics are, am I successfully exchanging data between my machine and the BACnet client software? Okay, which YABE is what we're going to demonstrate. You could be using commercial software, for instance. Am I getting data exchange that's accurate? Okay. Now, when you configure your OCS controller to support BACnet IP or BACnet MSTP, you can assign status registers and status variables so you can see from the controller side if everything's working as planned. So you're going to want to take a look at those during your testing to make sure you're getting reasonable values and that they indicate everything looks good. And then from a personal standpoint, you want to make sure that you as the application or automation engineer are comfortable and ready to install the equipment and that you're up to date and that you've got some confidence that that BACnet connection is going to work the way you want it to. Okay, now from the standpoint of those status variables that I talked about a minute ago, with BACnet IP, there's really only 3. Okay, there's 4 double words that are assigned and only 3 of them have any meaning. And the one you're really looking for is the good frame count. So if that particular value is incrementing on a regular basis, then you're looking good. And if your no frame counts and bad frame counts are hovering near 0 and not counting up, on a typical basis, then that's what you want as well. So with BACnet IP, status is very simple. You've got 3 words that you're watching, 1 that you want counting up and the other 2 you want sitting around 0. Now with MSTP, there's more involved from the standpoint of the communication interface. It's not simply Ethernet. So there's a bit more data available to you. The reality is what you're really looking for, again, is you're looking for your good message count or your good frame count to be incrementing. That's the biggest thing you're looking for. Now, in the case of MSTP, because it's a token passing scheme and the OCS, for instance, is going to be attempting to pass the token maybe to a device that doesn't exist, it's not uncommon to be getting no frame counts and those sorts of things incrementing pretty regularly along with the good frame counts. But as long as that good frame counts is going up and you're getting good data, then that's nothing to really worry about. All right, let's dive right in and test BACnet IP using our YABE tool. Okay, so let's go ahead and test our BACnet IP configuration on our machine so that we're ready to go as soon as the installation occurs. We've got more confidence that everything's going to work the way we anticipate it should. Okay, so we'll just do a really quick review of the BACnet configuration. It's very similar, if not identical, to what I had last week, although last week we were focused on MSTP. I'll just very quickly run through it here. So we've got our X4. Now, BACnet IP is Ethernet based, so we do the configuration from the Ethernet button here. Have to make sure we at least have a basic IP address and net mask configured here for BACnet IP. And then down here under downloadable protocols, that's where we've selected BACnet IP server. Okay, so let me go ahead and check out the configuration on the network level. There's really not much to do on the network level, although I did take advantage of assigning a disable bit. If I twiddle that bit, I can effectively reset the BACnet protocol on the OCS controller, which might have some value in the future, maybe. And then I've also assigned, this is very valuable, I've also assigned the 4 status feedback words. Actually, they're double words by assigning this particular variable as BACnet IP status. So I'm going to have 4 32-bit words that we'll review once we actually do our testing. Okay, so you definitely want to configure those. All right, so that is on the network level. On the device level, okay, the name, you can name it whatever's convenient for you. The ID, this is that 22-bit maximum ID that has to be unique on the over all the BACnet networks at a particular facility or campus, for instance. So I've just chosen a BACnet ID of 57, okay, a device ID of 57. And then I haven't chosen to disable the device nor status, the device level status for BACnet IP. I will take advantage of that for BACnet MSTP, but not for BACnet IP in this case. Okay. All right. And then finally, on the scan list level, okay, we've configured 4 real values assigned to this array variable here. And then those are considered analog values from a BACnet perspective. And then we've also assigned 4 digital values through this array variable here. Okay, so it's a real simple configuration. 4 analog values, 4 digital values, nothing more than that. Okay, so that's pretty much all the configuration that I've got for my test system here. Okay. All right, so let's go ahead and see if we can test it. Let's go ahead and take a quick look before we fire up our BACnet client software. Let's take a look at what it looks like on the bench. Okay, there we go. So you can see we've got our 4 analog values all there on the screen, and we've only got 2 of the digital values on the screen. Again, just for test purposes and demonstration purposes. All right, so back to our computer. Let's go ahead and fire up YABE. YABE, yet another BACnet Explorer. Nice little piece of free test gear here, test code. All right, so how do we get started? Well, in the device area here, we right-click and say Add Device. And this is where you can add either a BACnet IP or a BACnet MSTP, or this is actually a BACnet point-to-point, which is an RS-232 type connection. Pretty rare, frankly, but if you want to do some testing, you could use that as well. We're going to go ahead and do BACnet IP here, of course. Now, in general, you're going to leave that at BAC 0. All right, you don't have multiple BACnet IP networks going on for this simple test. And local endpoint, that's the IP address of the computer running YABE, not of the OCS. That's important to know. So really, all I have to do here is hit the Add button, and bingo, it has immediately found our OCS, which is in theory controlling your machine that you're testing prior to installation. It's found its device ID of 57. It's found its name. Okay, BACnet server there. All right, and looks good. All right, it's also found all the different variables, all the different BACnet objects, if you will, have also been found. All right, so let's take a look at those and see if we can see the values there. All right, so we've got our 4 analog values. Let's double click here and take a look at the first one. Now, first of all, the name it gives that particular analog value is the register that it has been mapped to. Okay, so it doesn't show with a variable name or anything like that. It shows as %R101 because in this particular case, that was the register that this particular analog value was mapped to. And then, you know, they're going to be in consecutive. And because they're floating point, each one is going to take up 2 registers. So we've got 101, 103, 105, and 107. And in the case of the binary values, those are mapped to M's. I specified starting at M97, so they are just 97, 98, 99, and 100. But let's take a look at this first analog value here. Looks like it's got a value of 800.5. All right, let's take a look at the bench and see what that reflects. Looks like that reflects the oven set point. Let's make a change to that. All right, and then head back to YABE and see the change. Oh, wait a minute, the change hasn't happened in YABE. What's going on there? Well, by default, YABE is only going to query this value when you double click on that particular variable or that particular object. So let's take a look at the next one and then go back to the first one. Now we can see it's actually changed. Now, another thing we can do is we can actually set up a subscribe, okay, so that if we hit subscribe, now we can say how often in seconds do we want to actually continuously poll for that particular object. So if we set that up for 3 seconds, now when I make the change, let's go back to the bench here to make the change. Now when we go back here, within 3 seconds, we should see that value change, and we did. Okay, so that did absolutely change up here, because this is where that updated data comes in. All right, so and if you want to get rid of your poll, you can just highlight that and hit delete on your keyboard. All right, let's verify we can actually change it on the BACnet side, on the YABE side. Okay, so we're set at 799. Let's change it to 802.3, let's say. All right, it's a floating point value, so that's why it's not exactly 802.3, at least as it's displayed here. Let's take a look at the bench. And there it is, 802.3. All right, very good. Okay, so that's pretty straightforward. One more thing I wanted to show you, and that is, let's take a look at the status that's happening and see if the status values are making some sense. Okay, so they are. Now we've got good responses happening, and there are no responses or bad responses. That's good. And the reason it's not counting up is because we don't have any of those subscriptions going. So YABE is not sitting there actively polling. It's waiting for us as the operator to double click on a value before it's going to go query it, or to make a change on a value before it's going to go write it. So that's why it's not counting up, but we don't have no responses or bad responses, so that's good. Those numbers should be very low in a typical test setup. 0 is preferable, of course, and everything looks good there. Now with BACnet MSTP, we've got more status variables to look at, and they're not always going to be all at 0. We'll talk about that when we get to BACnet MSTP testing. All right, so that is testing of BACnet IP on the shop floor. Okay, if things aren't going the way you want, what are some things that you can look at? Well, of course, you're going to want to double check your setup in Cscape. That's very important. Have you set the device ID the way you want it? Are the registers or variables that I want exposed to BACnet, have they been appropriately mapped? Has that been happening? And then is YABE set up correctly? Now, frankly, there's not a whole lot of setup to do for BACnet IP. So the likelihood is that it's probably got a really good chance of working on the first try. But again, those are some things to check if it doesn't. All right, now let's dive into BACnet MSTP testing. Okay, now let's take a look at how we'll test BACnet MSTP. A lot of similarities, but a few differences here. Okay, first of all, from a configuration standpoint, I think you'll see the configuration is very similar as it is to IP. But instead of going into LAN to do the configuration, we go under serial ports. And then MJ2 is the RS-485 port. On the network level, the key things here are to set our baud rate properly. 38400 is the default, so that's probably what you want to leave it at. N81 is where you typically want those. And then BACnet MSTP here, and then everything else really doesn't matter. Except for, you're definitely going to want to take advantage of BACnet status, which in this case is 8 32-bit words instead of 4 like it is with BACnet IP. Okay, so that is on the network level from a configuration, and I also did the BACnet disable variable here, although that's certainly optional and probably not all that useful with BACnet MSTP. Okay, under devices, this is where, again, we configure our device ID. And the device ID is a 22-bit value up to a 22-bit value, which means it's up to 4 million or so. We've also got our name here. Under configured device options, this is where we set our MAC address. And this is where we set our MAX master. You can get more details on MAX master by going back and reading last week's program. But effectively, MSTP is a token passing protocol. So if the OCS has MAC address number 3, when it has the token, it's going to use that token. And then when it's done with the token, it's going to pass it on to the next one in the list. Now, the only exception to that, which would be number 4, the only exception to that would be if the max master is set to the same value as the OCS's MAC address. If that's the case, instead of going to number 4, if the max master is set to 3, it's going to go to 0 instead. It'll go back down to 0 instead. So effectively, the token passing goes from 0 to the max master. All right. So that's the configuration on the device level. There is some additional device level status we'll take advantage of here. One variable array with 3 pieces of information in it. All right. And then on the scan list standpoint, we've got the same data that we had set up for IP. And that is 4 floating point values and 4 Boolean values. All right. So that's the configuration again for BACnet MSTP. All right. Now, I can show you the screen later, but the screen on the bench unit looks exactly the same as what you saw with the BACnet IP demo. So I'll just show you that later when we go through the status, which has changed quite a bit. So for now, let's just fire up YABE. Okay, and I've closed it, so I'm going to fire it up from scratch. Okay, there we go. And just like before, I start up here in the device pane, right-click and say Add Device. But this time, my configuration is going to be done through here. Now, because I'm not just communicating over Ethernet, I have to have a physical RS-45 connection with my test unit. And in my case, that's a USB to RS-45 adapter that after installation happens to be mapped by Windows to COM7. Okay, baud of 38.4, which is the default, looks good. Now, what about these parameters here? Okay, source address, that's the address of YABE. Okay, so anywhere between 0 and 127. And max master, that basically tells YABE that the highest master is 3. Master address is 3. So YABE is going to actually pass the token on to the next one in line, but it's not going to find a 1 or a 2 in this particular case. So let's go ahead and just add YABE and see what happens here. Now, one thing that you'll see that's very different is you see all these quote-unquote free devices on the tree, all right? And then finally what shows up is the HE-X4 with a device ID of 57. So these are all addresses, MAC addresses, that have been scanned and they're showing as being free because there are no devices that are utilizing those particular addresses. But let's go ahead and take a look at our X4 here. All right. And just like before with IP, we've got our 4 analog values and our 4 binary values. Okay. It's going to effectively work the same way it did with IP from this point forward. So again, we can double click here. See the current value is 802.3. Take a look at the bench. Yep, there's that oven set point at 802.3. We can make a change from here. Head back to YABE and not see a change until we double click on that device again or on that particular object again, and then we can see it's been updated to 804. And then just for grins, let's go ahead and work on our binary values here. So our first binary value is showing as a value of 0. When we go look at the bench, we can see that's correlating to the burner variable there on the upper right-hand corner. So let's change it from here. Okay, just to show that we can. All right, and then head back to the bench and see that it has been updated there as well. Okay, so we've pretty much proven out that we can see the data we need to see from an analog value and binary value standpoint. The one thing we haven't looked at is our status, which is quite a bit different for MSTP than it is for IP. Let's take a look at that now. Now, this is something we need to take a look at because our good messages are absolutely counting up nice and steady. All right, everything's looking good there. All right, but we are getting some no responses. Why is that? Well, that's because little bit of speculation here. That's because effectively, remember, there are empty nodes on the network that wouldn't be responding, for instance, when we pass the token. So I'm not too concerned about the counting up of the no responses. I'm really more encouraged by the counting up of the good messages than anything else. So that's a quick look at the BACnet MSTP status, which really the most important thing is our good message count counting up. Now with MSTP, if it doesn't go as planned, if you run into some hiccups, there's more to check. Okay, of course, you need to double check your Cscape configuration, make sure your baud rates are set the same on the YABE side as well as the OCS side of things. Double checking the wiring. You're not just plugging in a patch cable, you've got to double check your wiring. So you need typically a twisted pair. It's always a good idea to have a twisted pair and a common. All right, so in the case of the pinout you're going to need with the OCS, that's probably MJ2 is probably the port you're connected to. So that means pin 1 and 2 on that port are connected as plus and minus. All right, and pin 6 is your common, which is the common that's always a good idea to run if you can. All right, and of course the pinout on the 485 side, on the computer side, is going to vary based on the adapter you have. Okay. Now, if you don't have termination on your test network at your facility, if it's a little short stub of a network, it may not make any difference, frankly. So you might want to try it without termination first. But if that's giving you trouble, maybe you've got some error counts going up. You know, it's not just sitting at 1 or 2, it's going way above that with errors, not talking no responses, but errors. Then you may want to add some termination, and that would be a 120 ohm physical resistor, probably on the RS-45 adapter side of things. And then you can enable termination on the OCS side just by going to the system menu and turning it on, okay, under the serial port setup there. So termination is something you may need to deal with on your test network. And then possibly you might need to turn biasing on as well. Now, normally with BACnet MSTP networks, usually the biasing is handled by the router type device that's connected both to BACnet IP and to the BACnet MSTP network. So normally you don't want that turned on the OCS side of things. But if you decide for your test network that you need to turn that on because, again, you've got some bad frames happening and you've got termination enabled now, then you may want to turn that biasing on to make sure, and that may correct your issue. Now, one thing that's important to note is if you need to turn biasing on or termination on in your facility to get everything working properly, those may need to be off at your customer site, because at the customer site, the OCS or your machine may not be at the very end of the BACnet MSTP network, so therefore termination should be off. And again, biasing is normally handled by the router type device, so that should probably be off by default as well. So just a couple things there to check if things don't go as planned. Okay, this is the part of the program where I tell you we're here every Tuesday at 2 o'clock, although I have a shocking announcement coming up here in a minute. But you can always catch us on our YouTube channel, and whenever we're broadcasting on Tuesdays at 2 o'clock, we've always got someone standing by to answer your questions if you're watching live. And if you're watching on replay like so many of you do, then just give us those comments and questions in the comment section, and we'll do our best to get back to you very quickly. Okay, training schedule. Don't forget, we've got training scheduled for 2024. We'll have more classes coming later, but don't count on that. Sign up for these that have been announced so you can make sure you get your spot. You can interact with us a lot of different ways online, whether it's on our website at hornerautomation.com, whether it's on our Horner APG YouTube channel, or whether it's on LinkedIn. We'd love to interact with you online. We'll see you soon there. Okay, now the shocking announcement. No live stream next week. Okay, we're going to blame it on the eclipse. The good news is, with the total eclipse that's happening, and Indianapolis is in an ideal location to view it, we're having a big event for a lot of our channel partners, our distributors and reps and those sorts of things. And it's happening around the eclipse. And we're also opening up a new Horner training center. So we're going to be excited to show you some videos later this month that highlight that big Eclipse event and highlight the new training center at Horner. But because of all the work we're having to do to get ready for that big event, I'm not going to have a video on April 9th. Okay, we'll have the rest of April's programming announced on our website very shortly. If you haven't subscribed to our channel yet, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. And for the first time, I think in about 2 years, we're going to miss a Tuesday, but it's for good reason. We've got a big event coming up, and you'll get to see some footage from that a little later on this month. Okay, so until April 16th, I guess, let's all get out there and do us some good.